Factor by substitution is basically just a fancy way to say that looks annoying, just make it look nicer so you can factor it. So instead of saying x plus y, because it's kind of weird to do it with a binomial, if you want to do it, go for it. But I just replace it with something. I usually use a, sometimes I use x, depending on my mood. But I would think we would agree that that looks a little bit nicer than that. And I can factor this pretty easily. So the a squared just splits up to a and a. That would be what, plus 6 plus 8? Doesn't matter what order you put them in. And then you just need to go back in the end and replace your a with x plus y. So my final factor form would be x plus y plus 6, x plus y plus 8.
I did 12 and 2. Why did I do 12 and 2?
Because 12 times 2 is 24. That's maybe why.
Yeah, there was a mistake made.
It happens.
But I did it the right way.
Yeah, okay. Well, you know the idea.
I did it the right way. I just thought that 12 times 2 is 48.
It happens to the best of us. Not a problem. All right. Did anyone have any other questions on that type of problem? Okay, so you'll see a few more of those in the packet. If you see something that you want to go over more today, let me know. But let's kind of get the last case out of the way, which is factoring cubics. And then that's really the last of the stuff we have to do. And then we'll just have some practice time, and hopefully that will get you a little ahead on your assignment. So we have two cases, the sum of two cubes and the difference of two cubes. I'm using a little space, so I'm gonna put up, these have like a little formula, so it's nice. It's like something that you're always gonna plug into, you can always refer back to. Difference, sorry. Of two cubes. So we are familiar with the difference of two squares, but now we have cubes, so something to the third power, that sounds a little funky. So the sum of two cubes, if we have two things being added together that are perfect cubes, we'll talk about that in a minute, what we do with them and put their cubic. The way we factor it is we're gonna have a binomial, which is kind of our bases, our x and our y, whatever's being cubed. And then you're gonna have a trinomial, that's x squared, that should be a minus xy plus y squared. So once again, a little formula. With those type of things, it takes just a few to get used to it. So we'll write it now and then we'll look at some examples about how we're actually using it. When we say the difference of two cubes is basically the same, the only thing that's changed is the signs. So that would mean that I would have two things that are being cubed and that are being subtracted. So that would be x minus y, x squared plus xy plus y squared. You can notice they're pretty much the same thing, the signs are changed. As you're getting used to it, you'll start to get used to, okay, like this is what I do. Sometimes the one thing we forget is like, oh, what sign do I put? Is it a plus? Is it a minus? I can't remember. So one way I remember the signs is I think of the word soap, which means a whole lot of nothing right now. But as in terms of the sign, it means same, opposite, always positive. So I'll show you what that actually means. But in my head, I still say soap to myself sometimes because I know how to do all the steps. I'm like, oh shoot, is that positive or negative? So see how this is a plus. So when I say soap, that means this is the same, this is the opposite, and this is always positive. And then the same thing for this. Since this is a minus, the signs are the same, opposite, always positive. So it's just a quick little way to remind yourself, because you need to know this for next Friday. So just as a heads up, if that's something that you're like, you're not so sure about what goes where, write that down now. But the more you practice, the easier this is going to get, because it really is just like the same steps every time. So let's look at an actual example here. So I look at that and I say, that is a sum of two cubes. Now, when we do a difference of two squares, we take the square root of both terms. When we do the sum or difference of two cubes, we're going to take the cube root, okay? So the nice thing is your calculator will do it for you, especially when some of the numbers get a little bit bigger. You don't necessarily want to be sitting there and I'm guessing you're checking. So remember cube root, you're finding what is being multiplied by itself 3 times to get that number. In your calculator, you should have a symbol that looks like this. So if you have your calculator, I would try to find it. Some people, if you don't have a cube root, you might have one that looks like a square root with an X, and you put a 3 out front. But it's gonna make your life easier if you know where that button is. Because when we get to things like, I don't know, if I did like 12 cube, you'd have to find the cube root of 1728. You don't wanna be sitting there guessing and checking that. So your calculator will do the work for you. You're gonna see, once you know what the cube root is, it actually makes the answer pretty easy. So that's the main goal, finding cube roots. So here's how we go about doing this. We take the cube root of 8. What's the cube root of 8? 2. Because 2 times 2 times 2 is 8. So what multiplied by itself 3 times? What's the cube root of x cubed? X, right? Because I'm saying how many, if I have a cube and the cube root, they cancel each other out. We keep the same sign. What's the cube root of 27? 3. So if you don't know those, then throw them in your calculator. If you don't know how to use your calculator, ask me because I can help you. Okay, that's what we just found. We just found that binomial. So without that much work, just remembering to use cube roots, we have a good amount of what we need. And that's the most important thing because everything from here on out is based off of this. So then to find this other part, the trinomial part, you're going to square this first term. So that would come out to be 4x squared. You then multiply these together. That would give me 6x. Oops, excuse me, because this is going to be an opposite sign. And then last, you square the last term. Always positive. I just check my signs because sometimes I just go crazy. If this is a positive, then that's the same, that's the opposite, and that's always positive. Or you can just live by your formula. And that is your factor form. This is not factorable. So just as a heads up, you're just gonna get the trinomial there. But it's not bad. Once you do your cube roots and it gives you that binomial, then everything's based off of those numbers. So just make sure, once again, if you need help with cube roots, let me know, especially when they get a little bigger. They might not be as easy to necessarily guess and check. Yep.
I can't find like the.
Oh, I will show you.
Cube root button on my phone.
Hold on, let me sanitize my hands. So I can push it.
I have a grass.
Yep, that's fine. I know where it is. If you hit,
I know where the square root is.
hit math,
Okay.
and that's the 4th one down.
Oh.
So it's kind of hidden in there. So then, like, if you do the cube root of 27.
Okay, because I never used that button.
Yep, yeah, the math
Alright,
button is
thank you.
your friend.
I'm having this shit.
Oh, what is it?
Okay.
Do you have a calculator?
I'm just,
Okay.
it's
All
more
right,
of a
okay.
process.
Okay, let's
Not
put
their stuff.
See, how do you get that? You multiply the 2x and the 3 together to get the middle. See what it says xy, your 2 terms. You just multiply and get the middle term.
And then this is you
3 squared.
square.
Hmm?
Oh.
Sure?
Yeah.
All right, let's try another one. This is one of those things, like, the more you do it, you're like, oh yeah, like, you just kind of, the more you do it, the easier it gets type deal. So let's do another one. We'll do that.
Oh.
Got it?
Yeah.
Okay, you got something. All right, so let's say I did this one, and I said, hey, this is a difference of 2 cubes. That's not a difference of 2 squares. Technically, I can take the square root of 64, but I can't take the square root of 125. It's not a perfect square. So squares is out. This is a difference of 2 cubes. So what I'm going to do is take the square root, the cube root of the first term. The cube root of 125 is what? 5. Hey, what's the cube root of y to the 6th?
What is it? Set?
Y squared. You basically would just divide it by 3 to figure out how many cubes are there. So that would be y squared. What's the cube root of 64?
No, because that's the square. 'cause
That's a
eight,
square
eight,
root, I know, you get it.
Eight, eight, when's the sword? Why Nintendo 64?
There you go. What's the cube root of 64?
Did you learn that? 4.
4, okay? And then, going off our signs, this is gonna be the same. Once you have that binomial, everything is based off that. So now as we get our trinomial, our first term here, we're gonna square this. That would give me 25y to the 4. This is an opposite sign. We multiply these two terms together to get the middle, so that would give me 20y squared. Always positive, you square the second term, and you're done. So again, especially with the formula, you're doing the same thing every single time. The main goal is get those cube roots in the beginning. Excuse me, so everything is correct based off those. Any questions on that? I'm gonna do one more with you, and then I'm gonna have you guys try one just to kind of see how you're feeling, if you're getting used to what's going where. There's a bunch of these in your packet. So once again, the more you're practicing and the more good examples you have now, the hopefully easier it will be then. So I want to do this one with you for a reason. So if I look at that and I'm like, hey, that's a sum of 2 cubes. I'm like, wait a second, that says to the 4th power. Wait a second, if I try to do the cube root of 108, it is not a perfect cube. That's hinting towards one thing, and it's hinting that I need to.
Greatest common factor.
Thank you. You shouldn't do this every time, no matter what the factoring problem. Do a quick check and see if there's a greatest common factor. But you know if you're doing a problem, you're like, this isn't working the way it should be. That's usually also a hint that there's probably a GCF. So if you had tried to do the cube root of 108, it would have been a hot mess. So there is a GCF. These are both divisible by 4, and they both have an x in common. So I'm going to divide that out. What's 108 divided by 4? 27, x to the 3rd, plus 125. Beautiful. Okay, so that's looking better for what the setup that I need. So now we're going to use cube roots. The cube root of 27 is 3. The cube root of x cubed is just x. Remember you said you can just divide it by 3. You're just seeing how many cubes there are. Plus, because we're doing the same sign, the cube root of 125 is 5. If you can get that, you can get the rest of it, but that's the most important part, getting that binomial. Any problems getting that? Don't forget when you're giving a final answer, if there was a GCF, you need to bring it down. It is part of the final answer. And now we need our trinomial. So we're going to square the first term, that's 9x squared. Opposite sign. Multiply those together, 15x. And then always positive and square the last term. And that would be our final. So sum and difference of cubes. It is a little formula, but hopefully you're kind of just getting used to what you do. Using those cube roots is going to be the big thing to find that initial binomial. And then the trinomial is kind of based off of those terms. So once again, the more we're practicing, hopefully the easier it's getting. Any questions or problems so far?
I just have a question about, so like, if you like say like got like the top, like 108x to the 4th plus 500x, and it just said factor, how, like.
So in your mind, so I'm gonna go over this next week. We have a review one day, and I go over like, what do you do if you see 2 terms, right?
Yeah, like
So you would look at it and be like, all right, well, I technically have 3 options. It could be a sum of 2 cubes, it could be a difference of 2 cubes, or it could be a difference of 2 squares. That's the only 3.
And if you can tell, you know that they're not squared.
If
But how do you know the difference of if it's the sum of 2 cubes or the difference?
Yeah. Exactly. Well, how do I know?
Yeah.
Well, if there's a plus, it's sum.
Oh. Okay.
If there's a difference, it's minus. And then you're just looking, can I take the cube root or can I take the square root?
Okay.
Is there well, that one, there was a GCF. But once you took this GCF out, that's not a difference of two squares by any means, because you can't take the square root of either of those.
Yeah.
You can take the cube root of them. So that's just how you know, that's how you check. Yep,
Can we simplify it further by multiplying the 4x back in?
you would just leave it out, because when we factor, we take the GCF out, so you would just leave it there. You wouldn't even, don't do the extra step, it's not, you would, when I say factor, you would take the GCF out. So just leave it out there. Don't do more work than you gotta. All right, can you guys try this one? So in general, if I said, hey, can you try this on your own? See if you can do it now. So I'm giving you 512x to the third. So you might not know the cube root of 512, but you can use your calculator to find it. If you need calculator help, let me know now. Same thing with 343. So I give you a little bit of a higher number to see.
I need calculator help.
Can you use that calc to your advantage?
Which question is it?
It's so cube root, sorry, there's different.
Am I in the recording?
Yeah.
Ah!
It's
Oh my
fine, I don't think anyone's gonna even watch it, but it's fine. So you have this little button right here, and if I hit it, it looks like that.
Okay.
So if you want a cube root, you just have to put a 3 in front. So the cube root of 512 is 8.
Thank
You just put a 3
So
in front. So
that
kind of- Yes.
Alright, okay, awesome. That's so weird.
I know. Sorry. My life is just awkward.
You're always on camera now.
No, I don't think I've had anyone, or one person got dismissed the other day, so I was like, oh, I should record this. But they've already done the whole packet, so I'm sure they didn't need it, so. The odds of someone watching this are pretty slim.
Okay, sure.
Keep it up just for resources. In a few seconds, we'll go over that one. All right, so let's look and see if you're on the right track, if you have any questions, and then we'll kind of just glance over that packet again, see the sections, what you need to know, and I think there was definitely one I wanted to go over here. So cube roots first. The cube root of this is 8x, same sign. The cube root of this is 7y to the 4th, beautiful. So you just divide it by 3. Okay, so we have our binomial, feeling good. We need our trinomial. We square the first term, that would give me 64x squared. We multiply these together, which would give me, I'm gonna do the opposite sign. What's that, 56xy to the 4th? And then I'm gonna square that last term to give me always positive 49y to the 8th, right? And that would be your final answer.
That's a weird one. I get it now.
Like the answer or just
Yeah,
the
just
process?
the answer.
Yeah, sorry, some of them are just weird answers. All sorts of funky stuff going
My
on.
brain hurts.
Sorry.
Like I understand it, but I'm like.
It's just like sometimes I have to like do that extra second of thinking and it hurts my brain a little too. But that's the last type of factoring. So we've done a few problems, you have a few things to at least look back at. So, kind of looking at this packet that you guys got yesterday, it's broken into 5 sections. So the first, we kind of looked at it quick yesterday, that's like your original factoring from last year. There's maybe like a few little things sprinkled in, but in general, it's really just like finding those pairs that are working, what combination works as you fill things in. Part 2 was GCF. You see that all the time, that's kind of sprinkled throughout, so always look for GCFs. Difference of 2 squares, factor by grouping. So that's what we saw, kind of 4 terms, what do we do? Part 3 was factor by substitution, which we talked about in our warm-up today. If it looks weird, just replace it with something else to make your life easier. So that's section 3. Part 4 were cubics. So now part 4 you should be able to do. Nothing's too crazy there. It's pretty much, doing the cube roots. I think 1 or 2 has a GCF, so just be on the lookout for that. And then the last section is mixed review. I wanted to do one with you, and I wanted to do part 3 at number 14.
Would you combine like that?
I'm gonna show you.
Okay. No, there's no one terms combined yet.
Exactly, there's nothing to actually combine, that's why it's like, what do I do?
Hard.
Okay. So when I look at that, there's 6 terms. We haven't really seen anything with 6 terms. We're probably saying, there's nothing to actually combine together. There's just like a bunch of stuff going on. So what we're gonna do is kind of group things together that are related and then see if we can go from there. So when I say group things together, I just start to go through. This has an x squared. This has a xy, and this has a y squared. So what I notice is this xy kind of relates those two. I'm gonna make a group with those. Because once again, if I make anything really more than 3, I'm kind of setting myself up for failure here. As I move over, I look what's left. Oh, I notice these have a GCF. That's kind of just by itself. So I'm gonna group these together because I know they have something in common, and then we have that. So let's see what happens. I can factor this. This factors to x plus y, which I'm gonna write as x plus y squared. I can factor this because there's a GCF of positive 4. If I take that out, I'm left with x plus y. And then we just had that like random little minus 45. So the main goal of doing that is now we have a factor by substitution problem. You can replace x plus y with whatever you please. You can factor it. 45 would be plus 9 minus 5. And then you can just plug it back in. And your factor form would be x plus y plus 9, x plus y minus 5. So basically what someone did is they took this and they put it in, they like kept multiplying out and gave you this. And you're saying, what the heck is that? So you have to kind of work backwards to kind of group things together so you can get it in factor form, and then you can actually factor it from there. So I wanted to show that one to you. The one after that is very similar, number 15, I believe. So since you have the CD, you would group the C squared over to the D squared, those 3. And then the 3C and the 9D you group together, and then you kind of have a minus 10 at the end. So I wanted to show you that. That's one I wouldn't expect you to just be like, hey, I know how to do this. Like, cool.